Chapter 17, Test of Significance, the basic. So here, what we are going to talk about, we are going to talk about hypothesis testing. What is the meaning of the hypothesis testing? Why do we use it? Again, in chapter 16, we discuss about the confidence interval, right? Confidence interval. In the confidence interval, we try to find a range for the mu. As an example, we can say A to B. That is a range. But in this chapter, we are going to check that our claim is right or wrong. So, as an example, you see, need to check whether as an average, the milk bottles labeled as 1 gallon are filled with exactly 1 gallon of milk. So what we need to do, we need to check this has exactly 1 gallon of milk. Understand that? So how do we do that? Mu equal 1. It means that is the average, right? We check the average. It is a 1 or not. It can't be less than 1 or it can't be greater than 1. Right. Next one is, want to test the smokers need an average sleep of at least 5.4 hours. At least 5.4 hours. Then what's the meaning of that? We need to check it needs 5.4 or at least mean greater than, right? Greater than 5.4. So this is the one we need to check. Is a claim. Next one, you see not only just one, here there are two groups. You see male population and female population. So we compare the average of those two groups. In what average? Average cholesterol level of female college student is less than that of male college student. How do we do that? So we check, we compare two average of groups, right? Two groups. So actually we are going to talk about this in next chapter. So right now we just focus to the problems like example 1 and example 2. Okay. So hypothesis, you see we have null hypothesis and alternative hypothesis, two hypotheses. So we use H0 for the null and HA for the alternative hypothesis, or you can use H1 also, right? HA or H1. Then you see a hypothesis to be tested. We use the symbol H0 to represent the null hypothesis. And a hypothesis to be considered as an alternative to the null hypothesis, we use the symbol HA to represent the alternative hypothesis. Now consider these three. There are three types of hypotheses. First say two-tailed test and left tail and right tail. Actually, these two both are one tail. One tail, or we call one-sided. One-sided test. Okay. So you see all of them has equal sign under H0. Yes, it is equal sign. Always in this class we use equal sign only. Okay, equal sign only. But here, how do we know it is two tail? Yes, if you see not equal sign, then this is two-tailed test, or we call two-sided. Okay, two-sided test, right? How do we know that? Because of unequal under HA, under alternative hypothesis, right? But left tail, you see this in this side, mu mu less than mu naught, then it is left tail. But if mu greater than mu naught, then we call it is right tail. Okay. So as an example, let me write down this. So actually, if we go to the first one, is say we need to check gallon 1 liter. So mu equal 1 versus HA mu not equal 1. So you see this not equal sign, right? So then it is two-tailed test, right? But if you need to check if it is less than 1, so how do we check it? We write mu less than 1. Then it become what? It become one-tailed test and left tail. You got it? One tail and left tail. You see mu less than 1. Okay, that's why we call it is one tail and left tail. Similarly, right tail should be the same H0, but we can write down HA mu greater than 1. Okay. You see, I explained here. Please read these definitions so then you can understand very clearly. And here I show the same thing using the diagrams. So go over this again so you will understand. Now let me discuss these examples. Define the hypothesis for following research questions. Classify them as left-tailed, right-tailed or two-tailed test. Need to check whether as an average the milk bottles labeled as 1 gallon are filled with exactly 1 gallon of milk. Exactly 1 gallon of milk. So then what is the null hypothesis? That is H0 mu equal 1 versus HA mu not equal 1. Understand that? But again you should know this one. We never use statistic under hypothesis. Suppose, do we need to check this one versus HA x bar not equal 1? Do we need to check this? No. Why? It is x bar. X bar can be calculated. Right? X bar can be calculated. Okay. Therefore, we never use this. Okay. X bar. We never use statistics. Right? We never use statistics. But parameters. You know parameter. Mu is a parameter, right? So that's why it is. We don't know that one. It is an unknown. That's why we need to check that is right or wrong. Okay. Right. So next one. Want to test that the smokers need an average sleep of at least 5.4 hours. At least 5.4 hours. Then as usual always mu equal here and H0. So mu equal 5.4. But we need to check at least 5.4. Therefore mu greater than 5.4. Okay. And other thing you should know, we don't use any equal sign like this under HA. Okay. We don't use that here. Okay. Next one. It is believed that a machine makes chocolate bars that are on average 5 grams. A worker claims that the machine no longer makes 5 gram bars. Okay. What is the meaning of that? It doesn't say it make less than 5 gram or it doesn't say greater than 5 gram, right? It just say it doesn't work properly, right? It doesn't work properly mean what? It doesn't make 5 gram bars. Understood that? Okay. So then what do we need to check? We know it is H0 mu equal 5, but under HA it should be mu not equal 5, right? It can't be less than 5, can't be greater than 5. Understood that one? Okay, what is this? It is one tail or two tail? Is it one tail or two tail? It is two tail. Why? Because of this. Not equal sign. Therefore, this is two tail. How about this then? Is it one tail or two tail? This is one tail. This is one tail. And is it right tail or left tail? It is right tail. Okay, it is right tail. It is right tail. Understood that? Right. A snack company produces a 454 grams bag of cookies. The quality assurance department performs a hypothesis to decide whether the mean net weight of all bags packaged is 454. Okay, it must be 454 grams, right? Therefore, what should be the H naught? Null hypothesis. We know it is always equal sign, so this should be the always, but the number is 454. Then what is the alternative hypothesis? HA, that is mu not equal 454, because it can't be less than or can't be greater than. Understood? Okay. So then, what is that? Is it two tail or one tail? It is two tail. Why? Because of this. Not equal sign, right? Under A. Yeah, therefore this is two tail test. Two tail test. Okay. Next one. In 2005, the mean retail price of history books was 78.01. Suppose that we want to perform a hypothesis test to decide whether this year's mean retail price of history books has increased from the 2005 mean. So then what do we need to check? We need to check H naught. What is H naught? Mu equal 78.01 versus HA mu. We need to check increase, right? Increase of that price, therefore greater than 78.01. Okay, so is it one tail or two tail? This is one tail. This is one tail. One tail. This is one tail. And is it right tail or left tail? You see this one like this. Okay, mu greater than, therefore it is right tail. Or we can say one-sided and right side. Suppose that we want to perform a hypothesis test to decide whether the average adult with an income below the poverty level gets less than the 1000 milligram calcium intake. Okay, so how do we check this one? What is the H naught? We need to check average is 1000 or versus HA mu less than 1000, right? That's what we need to check. So we say less than 1000. So is this one tail or two tail? It is one tail. Because of this one tail, not equal sign, right? It is not the not equal sign. This is the inequality. So one tail. One tail test, and this is left or right? It is left, because you see it is in this side, mu less than, therefore it is left tail. Right, now let me explain how to check this one. Okay, how do we check? Yes, you can read these definitions, but I am going to explain them using examples. So we do some assumptions. Here you see a hypothesis test has 5 steps. Okay, 5 steps. The first one is assumptions. So we follow the rest of them for each problems. So main assumptions we assume X has normal distribution. I mean our data set has normal distribution. Mu is the population mean and sigma is the population standard deviation. And here you see we assume sigma is known. You see that sigma is known. Okay, sigma is known. Therefore, you can say sigma is known, but you know mu is unknown. That's why we are checking, right? We check the mu, right? Mu less than or greater than or equal to some number, right? Therefore, mu is unknown, because if we know the mu value, then we don't have to do this thing. Then we know already. So again, sigma is known, mu is unknown, right? So first thing, what we do, first read the problem, then set up your null and alternative hypothesis. It must be one of this. Okay, it depends on the problem. But you know always H naught, this one equal sign. But HA depend on the problems. Okay. Next step what we do, once we decide the hypothesis, null and alternative hypothesis, then we need to find the test statistic. How do we find the test statistic? So this is the test statistic. Z naught equal x bar minus mu over sigma over root 10. That is the test statistic. Okay, that is we use Z naught. Right, first step again for the problem, we need to set up the null and alternative hypothesis. The second one, we need to find the test statistic. What is the third one? Third one, find the p-value. How do we find the p-value? This depends on the alternative hypothesis. You see this HA, it depends on the HA, right? If HA greater than mu naught, it means that is right tail. If it is right tail, this is the p-value. This is the p-value, the area under the curve, and greater than the Z naught. What is the Z naught? This is the test statistic. That is the test statistic. Okay, so that is the p-value. So we write the p-value equal this, but according to the table we use Z table. We need to use the Z table. Therefore, this should be p-value equal 1 minus probability Z less than or equal Z naught. That is the p-value for the right tail test. I know it's still maybe you are not understanding this very clearly, but let me discuss examples, then you can understand. But right now, understand here the method, how to write steps. What are the steps we should follow? Right, the p-value here, left tail test, you know left tail test. So it is this area under the curve. So we can write the p-value equal probability Z less than Z naught. But if it is two-sided test, because of this sign, it become two-sided, then how do we find the p-value? P-value is the area this one plus area of this, the blue color area, right? So that is the one here. You see probability, this one probability Z less than or equal negative Z naught, that area, and this area is probability Z greater than or equal Z naught. You know greater than or equal or strictly greater than are the same. So then we can add them together like this. But you know normal distribution is symmetric. Therefore, we can use p-value equal 2 times probability of this. Okay, probability of, actually how do we do that? 2 times probability z less than or equal negative z naught this. That is the p value for the two-sided. Okay. Now we get the conclusion. How do we get the conclusion? Yes, we should compare our p-value with alpha. Alpha is the significance level. Okay, significance level. So if you see here, we reject S0 if the p-value is less than or equal to the significance level. That means if p-value less than or equal alpha, we can say we reject H0. H0 is rejected. So that is the condition. Okay, p-value less than or equal alpha. It can be equal or it can be less than. Right? Then H0 is rejected. Understand that? Once we get the conclusion, we can decision, we can get the conclusion according to the problem. Okay, now let me discuss these examples, so then you will understand. Okay, the mean annual expenditure per 25 to 34 year old consumer for health care is $1,468. This includes health insurance, medical services, and drugs and medical supplies. Students at a large university took a survey, and it was found that for a sample of 60 students, what is the 60? It is the sample size. Why? That is the sample. Sample of 60 students. The mean healthcare expense was 1520. It means, what is that? That is the x bar, right? Because x, that is the mean of the sample. Understood that? Mean of the sample. It is x bar 1520. And the population standard deviation is 198. So, population standard deviation. That is very important, but that is the key. But you are going to learn another method. Okay, so it depends on this part, because now you know sigma is given. Sigma is given mean what? Sigma is known, right? Sigma is known. Understand that? Sigma is known, right? Therefore, we can follow the step what we discussed just before. Okay, right? Is there sufficient evidence at alpha equal this? So alpha equals 0.01. Now read the rest. Conclude that their healthcare expenditure differs from the national average of this. What do we need to check? It is the same of the national average, or they say national average is 1468. We need to check it is right or wrong. Understand? Everybody? Right. So therefore, A, state the null and alternative hypothesis. So then you know H0 is mu equal 1468 versus HA mu not equal 1468. Okay. If you have any questions? No? Good. So then, tell me, is this one tail or two tail? Two tail. It is two tail. Why? Because of this part, right? Not equal sign, right? Then B, compute the value of the test statistic. What is the test statistic? It is Z naught. Z naught equal x bar minus mu naught. Mu naught is the value of mu under h naught. Under h naught, okay? X bar over sigma over root 10. Right. So x bar is here 15, 20 minus mu naught. Mu naught is 14, 68, that is under h naught, divided by sigma. Sigma is 198 divided by root n. N is what? 60. 60 square root. So you can divide, you can calculate this value. That should be 2.03. 2.03. Understand that? That is the test statistic. Any questions? Okay. Now see what is the p-value. Right. Before you go to the p-value, you should understand the alternative hypothesis. Is it one tail or two tail? It is two tail. You know already. Therefore, go back to the actual p-value, the naught. Let me explain. So now we know it is two tail, right? Two-sided. Then that should be this. Two-sided this, right? You see that. So then what is the p-value? P-value is this. You see, that is the p-value. Because of two-sided, right? So let me write down. Okay. So we can draw this one and here like this. So we know our test statistic is 2.03. So then we need to consider this area plus here negative 2.03 and this area. For the first one, let me write down this. P-value equal probability Z less than or equal negative 2.03 plus probability Z greater than or equal 2.03. That is the p-value. But you know this area and this area are the same, right? So we can use probability Z less than or equal negative 2.03, and here also we can use probability Z less than or equal negative 2.03. Why? These two are the same areas. Understood that part? Therefore, you see both are the same. Now we can write probability 2 times probability Z less than or equal negative 2.03. So now go to the table. 2 times table, go to the table, probability Z less than or equal negative 2.03. Go to the Z table, negative 2.03. You know negative 2.03 is here. You see that? Negative 2.03. That is over there, right? So it is 0.0212. So we can write down here 0.0212. Now we can calculate the p-value. P-value equal 224, 212, 224 and 0. So this is the p-value. Understand that? Any questions? Good. Then what is your decision? How do we find the decision? Yes, as I mentioned before, we need to compare p-value with alpha. So p-value, if p-value less than or equal alpha, we can say H0 is rejected. H0 is rejected. Here alpha is what? Alpha is 0.01. You see that it is 0.01. Therefore, we can compare this one 0.0424. That is the p-value, and alpha 0.01 alpha. Then which one is the bigger? It is this, right? Understand that? Actually, it is the opposite of the condition. Understood that? Because here we say if p-value less than or equal alpha, H0 is rejected. But this case, p-value greater than alpha. You see, it is greater than alpha. If p-value less than or equal alpha, H0 is rejected. Therefore, under this condition, we can say H0 is not rejected. H0 is not rejected. Understand that part? H0 is not rejected. That is the decision. Then they are asking E, what is your conclusion based on the problem? Yes, conclusion. How do we get the conclusion? Okay, let me explain this. H0 is not rejected. That is the decision. So what is the H0? H0 is this. What is the value of mu? Mu equal 1468. That is the H0, right? H0 says mu equal 1468. So mu naught, H0 is not rejected. Mean in other way I can say H0 is accepted. But we don't write that word, okay? Accepted. But in other way, right? It is not rejected mean accepted, right? Yes, that means we accept this one. We accept this one. That means that is right. That is correct. Understood that? Mu H0 is not rejected means it is accepted. That means mu equal 1468. Therefore, your decision is what? Your decision is, you can say national average is 1468. Or you can say the mean annual expenditure per 25 to 34-year-old consumer for healthcare is 1468. That is the decision. Understand that? Decision coming from the problem, okay? Conclusion, again, that is the conclusion, right? Conclusion coming from the problem, decision coming from the comparing alpha and p-value. Okay, right. Now, F. Is the conclusion different at alpha equal or 5? Again, as I mentioned just before, how do we get the conclusion? Comparing alpha and p-value. Right. Now, let me compare. What is the p-value? This p-value is what? 0.0424, right? Zero, 4, 2, 4. That is the p-value. So now what is the alpha? Say alpha equal 0.05. Alpha is now 0.05, p-value is 0.0424. 0424, right? Then which one is the greater? You see here p-value is less than alpha. You got it? P-value is less than alpha. Yes. Then actually this condition is satisfied. p-value less than or equal alpha, H0 is rejected. Here we got p-value less than alpha. Therefore, we can say H0 is rejected. H0 is rejected. So H0 is rejected. So what is the meaning of that? H0 is rejected means we don't accept H0, right? Okay. Here this is rejected. How many options we have? We have only two options, H0 or HA. If we don't accept or H0 is rejected, then we have only one option left. What is that? HA, right? So we have to go with this. What is that here? It says mu not equal 1468. That means the national average is not 1468. Understand that? So what is the conclusion? Yes, conclusion difference now. We can say that this one national average is not equal to 1468. Not equal to 1468. It is different, not the same. Any questions? Okay, second one. The average production of peanuts in the state of Virginia is 3,000 pounds per acre. A new plant food has been developed and is tested on 60 individuals. You see 60 individual plots, right? That means n equal 60. 60 individual plots. Okay, n equals 60 of land. The mean yield with the new plant food is 3,120 pounds of peanuts per acre with the population standard deviation. Okay, actually here you see x bar is 3120, the mean yield with the new plant food. Okay, new plant food, it is x bar. Then we have standard deviation. It is population standard deviation. That is the key. Because sigma is 578. And now we know, because of this is given, right? Because this is given, now we know we can use the method we discussed. Okay? Then alpha equal 0.05. Right. Can one conclude that the average production has increased? Okay. Then part A, what is the H0? You know H0 mu equal as always, right? It's always mu equal. The difference is the number. What is the number here? What do we need to check? Conclude that the average production has increased. So it first you see that was 3,000, right? So we need to check its increase. So therefore here should be 3,000, but HA mu greater than 3,000. So that is the null and alternative hypothesis. Any questions? Part B, compute the value of the test statistic. Yes, you know this is sigma is known. Again, before you go to the test statistics, check your information, given information. Because sigma is known, then we use this one. But sigma is unknown, it is different. Okay, therefore sigma is known, therefore we can say Z0 equal x bar minus mu naught sigma over root n. So we know x bar is 3120 minus mu naught is 3000 divided by sigma is 578 divided by square root of 60. So this is what? C naught equal 1.61. 1.61. So that is the test statistic. Before we go further, first understand this. What is this one? I mean, null and alternative hypothesis. It is a one tail or two tail? Is it one tail or two tail? One tail. Why? Because we have inequality here, right? Because of inequality, it is one tail. Right. Then it is right tail or left tail? Right tail. It is right tail because it is in this mu greater than, right? Mu greater than, therefore it is right tail. If you get right tail, normally this z naught value should be positive. Okay? Should be positive if you get a right tail. And if you get a left tail, normally it should be negative. But if it is two tail, it's hard to decide. Maybe positive or maybe negative. Understood that? So either one for the two tail, but left tail and right tail it change. Okay. Now see what is the p value. Right. Now you know this is one tail and right tail. Therefore you know the graph. If it is right tail, you know this is 1.61. So p value is the area under the curve, actually this area, and greater than 1.61, right? So this is the p value. So I can write p value equal probability z greater than or equal 1.61. So that is the area here, right? You see that? That is the area here. Probability z greater than or equal 1.61. So we can write 1 minus probability z less than or equal 1.61. Okay. So 1 minus, now go to the z table and check the probability 1.61. 1.61 is here. You see 9463, right? 9463. So you can write 0.9463. 9463. Then get the answer 1037,963,945,990. So this is the p value. Any questions? That is the p value. Then D, what is your decision? Okay, what is your decision? Again, tell me how do we get the decision? Comparing both p value and alpha. Okay, p value and alpha. So p value, if p value less than or equal alpha, reject H naught. Reject H naught. Okay, so p value here is 0.0537 and alpha is 0.05, right? 0.05, that is alpha. So which one is greater? This is the greater one. P value is greater. So you see, this is the opposite of the condition, right? Condition, I mean, H naught is rejected if p value less than or equal alpha. Okay, but this is p value greater than alpha. Therefore, H naught is not rejected. H naught is not rejected. That is the decision. What is your conclusion based on the problem? Okay, H naught is not rejected. That means H naught is accepted. In other words, right? We can go with H naught. We can accept H naught. Got it? So what it says the average is 3000. Therefore, yes, you can write the conclusion. The average production of peanuts in the state of Virginia is 3000 pounds per acre. Yes, that is true, right? Just write down that. Understand that?